Hi everyone, I am S Kiran. I am explaining introduction about signals and systems. In that part, the following topics are definition of signal and system, classification of signals, types of signals like deterministic and non-deterministic signals, periodic and non-periodic signals, even and odd signals, energy and power signals, comparison of energy signal and power signals, and we have to discuss some problems also. Okay, before going to the introduction, first we concentrate on what is signal. Yes, signal is a graphical and pictorial representation of given information data. Yes, absolutely. It is a physical quantity, varies with time, space, or any independent variables. Okay, coming to the definition, signal, dependent variable or function of one or more independent variables. Okay, now we can enter into the introduction about signals and systems. Okay, this is also called signal analysis. The concept of signals and systems play a very major role in different areas like communications, aeronautics, circuit design, acoustics, biomedical engineering, energy generation and distribution systems, control and speech processing. Yes, coming to signals, signals may be a function of time, temperature, position, pressure, distance, etc. Some signals in our daily life we can observe: music, your voice, picture and video audio signals. We can treat as a signals. Coming to exact definition of signal, a function of one or more independent variables. What is the point? A function of one or more independent variables which contains some information is called signal. Just you can concentrate once again this very important point. A function of one or more independent variables which contains some information is called a signal. Yes. Then what about system? Good, very good. It is a physical device. Coming to system, it is a physical device which is having some components. Every system having some components, right? It is a physical device which is having some components and their meaningful interconnections. Whatever having components, that components are connected to one by one, are formed, is nothing but system. Coming to definition of system, it is a physical device which is having components and their meaningful interconnections is called system. Okay. Yes, coming to signal, in electrical sense, a signal can be voltage or current. Everyone knows very well. Okay, current is the function of time independent variable, as an independent variable. Coming to our daily life, a TV signal, computer signal, mobile signal, radio signal, these are all signals daily we can observe. Okay, a common form of human communication takes place through use speech signals or face-to-face signal. Now my voice signal you can also observe now, right? With the help of signals, taking the images of objects or people. Okay, very good. We use signals sending electronic mails. Day-to-day life we can use internet. This is also signal. Coming to biomedical side, heartbeat, blood pressure of patients are some monitored through signals. Even ECG also it's a signal, right? Coming to the, once again we can concentrate on definition of the signal. A signal is defined as any physical quantity that varies with the time, space, or any other independent variables is nothing but the signal. Okay, then famous point is there. Any human activity is interaction of signals and systems. I mean, any human activity, observe, using signals and systems. Okay, next. Signals can be one-dimensional or multi-dimensional. When the function depends on a single variable that can be simply treated as a one-dimensional. The function having two or more variables that can be called as a multi-dimensional. That's fine. Okay. Coming to classification of signals, a very rigorous topic. Classification of signals can be classified into two types, broadly classified into two types. One is continuous time signals, another one is discrete time signals. In short form, continuous time signals is also called CTS. Discrete time signals is also called DTS. Okay. Now you can concentrate on definition. Very important. The continuous time signals, the independent variable is continuous. In discrete, the independent variable is discrete. Then you know. Okay. The independent variable for continuous time signal is t. The continuous time signal is represented by x of t. Just simply you can observe this graph. Okay. This is a continuous time signal. Okay. In x-axis t, y-axis we can represent as a x of t. X of t is a function of signal. Okay. Right. Now coming to the definition. A signal of a continuous amplitude and time is known as a continuous signal. Continuous signal is also called a analog signal. The signal will have some value at every instant of time. Yes, everybody, just you can concentrate this important word, that is called continuous is nothing but some value at every instant of time. This is very, very important point. So that's why it is called continuous time signals. Examples: sine wave, cosine wave, triangle wave, general examples like temperature, pressure and sound, etc. Okay. Continuous means some value at every instant of time. Okay. Now coming to discrete time. Discrete time signals are defined only at discrete times. Coming to continuous, what? Continuous, coming to continuous, at continuous. In the independent variable is continuous. Here the time signals are defined only at discrete times and different time intervals, right? This is called discrete time. That is only at certain instants of time for discrete time signals. The independent variables is integer n. We can identify integer n. A discrete time signal is represented by x of n. Coming to continuous, represented by x of t. In discrete time signal, represented by x of n. Discrete time signal x of n is defined only for integer values of n. Okay. Yes, simply you can observe this figure. There is a discrete time signal x of n. In x-axis we can represent with integer n. In y-axis we can identify with x of n. This is called discrete time signal. This is some information. This arrow mark plays very major role. Without this arrow mark, we cannot examine this signal. Okay, then this 0 is identified, n is equal to 0. These are all information. This is called discrete time signals analysis. Coming to definition, for a discrete time signal, the amplitude between two time instants is just defined, not defined. Okay, is not defined. Generally, a blood pressure recordings after every 1 hour, we can plot graph. Resultant signal will be a discrete time signal. Okay, continuous time signal is known as analog signal. Discrete time signal we can also call a digital signal. Okay, based on some parameters, these continuous and discrete time signals can be classified into following topics: deterministic and non-deterministic signals, periodic and non-periodic signals, even and odd signals, energy and power signals. Yes, first we can concentrate on deterministic and non-deterministic signals. Non-deterministic signals is also called random signals. Okay, later we can concentrate why it is called random signal. Okay, coming to deterministic signals, which can be completely specified in time. Okay, this type of signals are very regular and represented by mathematical equation or expression. Coming to non-deterministic signal, we cannot represent as a mathematical form. That's why we can call it as a random. Okay, coming to deterministic signal, simply we can represent by a mathematical equation. The nature and amplitude of such a signal at any time can be predicted. Examples: x of t is equal to bt, x of t is equal to a sin omega t, x of n, discrete time signal, 2, n greater than or equal to 0, 0 otherwise. Just simply you can observe the following figures, you can understand. Okay, right. Coming to non-deterministic signals cannot be represented in mathematical form. The two variations in these signals: deterministic signals can be represented by mathematical form, non-deterministic signal cannot be represented the mathematical form. Just you can see the signals. Okay, the mathematical expression of the sinusoidal signal x of t is equal to a sin omega t. This is called deterministic signal. Coming to this random signal, we cannot represent the mathematical expression because different amplitudes, different time periods. It's like a random, it's a noise signal. I think you can understand noise signals cannot be represented as a mathematical form. Okay, this is the main difference. Coming to second one, periodic and non-periodic. A signal which repeats itself after a fixed time period is called periodic. Very important. Which repeats itself after a fixed time, like t naught, okay, is called a periodic signals, which is having some expression. Just you concentrate on expressions, very important. Periodic signal is mathematically expressed as x of t is equal to x of t plus t naught. T naught, condition of periodicity. Very important this condition. In problems it is used, where t naught is a period of the signal x of t. The signal x of t repeats itself after a period of t naught seconds. Example: sine wave, cosine wave, square wave, triangle wave. Okay. Coming to non-periodic. Non-periodic signals is also called aperiodic signals. It does not repeat itself after a fixed time period. Very important, Andy. it is repeat itself, that is called periodic. It does not repeat itself, that is called non-periodic. The expression is x of t not equal to x of t plus t naught. Here the condition is for periodic, x of t is equal to x of t plus t naught. Coming to non-periodic or aperiodic, the condition is x of t is not equal to x of t plus t naught. Yes, you can see also example. This is periodic signal and deterministic signal also. Okay, coming to this one, this is a aperiodic signal, right? Examples, we can see examples in the following figures. One more important notation: periodic and non-periodic signals exist for both continuous time and discrete time signals also. Nice point, right? Periodic discrete time signals is given by equation. Whatever we discussed in the continuous time signal, same we can also discuss in the discrete periodic signal or periodic discrete time signal. Just divide into different time intervals. This is called non-periodic discrete time signal, right? Then coming to third one, even and odd signals. You know very well. Even signal and odd signal is also called symmetric and anti-symmetric signals. Continuous time even and odd signals. At the same time we can also discuss discrete time even and odd signals. Important condition is for time, for continuous time, symmetric or even signal is x of t is equal to x of minus t. Okay, x of t is equal to x of minus t is nothing but the symmetric signal or even signal. Then obviously x of t is equal to minus x of minus t is nothing but asymmetric, anti-symmetric or odd signal. Again I will repeat, continuous time even signal is said to be a symmetric or even. Condition is x of t is equal to x of minus t. Anti-symmetric or odd signal, x of t is equal to minus x of minus t. You can see some examples. Cosine wave. Okay, symmetric signal is cosine wave, anti-symmetric signal is sine wave. Just you can see the figures also, right? Sine wave is a symmetrical, cosine wave is a symmetrical. You can also observe in the discrete form. Okay, x of n is equal to x of minus n. This one x of n is equal to minus x of minus n. N is a integer. Okay, right. The next, after that discrete time even and odd signals, you can see here. Okay, coming to fourth type, energy and power signals. A very simple topic and important topic. Coming to energy signal, it is a finite energy. Coming to power signal, it is a finite average power. A signal is said to be an energy signal if it is having finite energy and zero average power. The condition is 0 less than r less than e less than infinity and p equal to 0 is simply said to be an energy signal. Coming to power signal, a signal is said to be a power signal if it is have finite average power and finite energy. 0 less than p less than infinity and e is equal to infinity. One more point, if the signal does not satisfy any one of the above two conditions, then it is neither energy nor power signal. Let us discuss about some equations. Consider the following circuit. In that circuit, input voltage is x of t or voltage x of t, parallelly connected with resistor, that is called R. Okay, then we can find out the current. What is formula for current? V is equal to IR, I is equal to V by R. Here V is equal to x of t, so I of t is equal to x of t by R. So what is formula for power? Power is equal to V into I. We can write in time. P of t is equal to V of t into I of t. Now V of t is equal to X of t voltage. Now substitute V of t and I of t values in P of t is equal to V of t into I of t. Then finally we get P of t is equal to X square of t by R. Total energy we can write integral. Total energy in continuous form we can write integral. Coming to discrete, we can write some sigma. Okay, E is equal to minus infinity to infinity the function x square of t by r into dt. Integral means it is total energy. For example, if R is equal to 1 ohm, the energy dissipated is equal to minus infinity to infinity x square of t into dt for real signal. Okay, if it is complex values, simply you can put as a mod. Okay, discrete time signal, very simple. E is equal to sigma, n is equal to minus infinity to infinity x of n modulus whole square. Okay, mod square. Yes, you can see this example or waveform, an energy signal or a signal with finite energy. Okay, the following figure is observed. A signal amplitude does not become zero, then that's why t tends to infinity, the signal will be infinite. So one important notation is all practical non-periodic signals which are defined over finite time are energy signals. They are also called a time limited signals. Okay, then next, average power. The power, average power, already we discussed it so many times. Average power limit some t tends to infinity 1 by time period. T means time period, minus lower interval. Okay, lower interval to higher interval, or minus t by 2 to t by 2 with function x square of t into dt. That is average power equation. If it is complex, simply you can put mod. P is equal to limit t tends to infinity 1 by t minus t by 2 to t by 2. Okay, x of t whole square dt. That's fine. If it is discrete, simply we can write n is equal to minus n by n sigma n by 2 x of n whole square. Okay, this is, you can observe some external power signal in the following figure shown, right? This is average power signal. Now very important topic, comparison of energy and power signals. Energy signal. Okay, very important. There is a chance to ask in final examinations. Power signal. Total normalized energy is finite. Already I discussed energy is finite. Coming to power is power signal. Power is finite and non-zero. Good. Equation, E is equal to minus infinity to infinity x of t mod whole square dt. Okay, P is equal to limit t tends to infinity 1 by t integral minus t by 2 t plus t x of t whole square dt with mod. Coming to energy signals, non-periodic signals are energy signals. Coming to power signal, practical periodic signals are power signals. These signals are time limited. These signals can exist over infinite time. Power of energy signal is 0. Energy of power signal is infinity. Already I have discussed in the conditions of energy signal and power signal. You can understand. Examples, rectangular pulse like is a periodic pulse train. You can also concentrate some problems. The first problem is given signal A sin omega t is periodic signal or not. Very simple. X of t is equal to A sin omega naught t. Okay, what is the condition for periodic? Just you can check. X of t is equal to x of t plus t naught. Okay, simply substitute t, replace with t plus t naught. Okay, x of t plus t naught, then the given function A sin omega naught t is converted into A sin omega naught t plus t naught. Just you can find out omega naught, some angular frequency omega naught is equal to 2 pi f naught. T is equal to 1 by frequency, substitute T naught value in the sense of 1 by f naught. Then coming to omega naught into T naught is equal to 2 pi f naught into 1 by f naught, only 2 pi. This 2 pi substitute with the omega naught with the T naught. Then final expression a sin omega naught T plus 2 pi. This value 2 pi, some all silver teacups are a sin 360 degrees plus omega naught T, simply we can call sin omega naught T, or you can do sin A plus B, sin A cos B plus cos A sin B. Finally you get x of t. That's why it is called a periodic, is proved. Periodicity is also proved. This coming to second problem, exponential signal is obvious, it's a non-periodic signal. Just you can see the problem because it's not touched the 0. One cycle period t tends to infinity. Then coming to x of t plus t naught is equal to substitute these values, e power of minus 80 into e power of minus 80 naught. From figure you can write t naught is equal to infinity. Then coming to x of t plus t naught, e power of minus 80 into e power of minus infinity. So final expression x of t not equal to x of t plus t naught. That's why it is not, exponential signal is a non-periodic signal. The third one, there is a gate examination problem. The following figure, fundamental frequency of waveform shown is figure, phi in frequency and radio per second, very simple. Frequency, this is considered a full cycle, that is the time period t naught is equal to 0.2. Waveform starts from here to here, ends with this one, so the time period is equal to 0.2. Based on time period we can also calculate frequency, f naught is equal to 1 by t naught is equal to 1 by 0.2, then 5 hertz. Angular frequency omega naught is equal to 2 pi f naught. Substitute f naught value, you get 31.418 per second. Fourth problem, good one. Fundamental frequency of the discrete time square signal. Just let us count this, how many integer values here. 1 2 3 4 5 6 7 8, then n value is equal to 8. Now coming to the solution, so fundamental frequency of x of n is given by 2 pi by n. You know the n value is equal to 8. Then fundamental frequency some omega 2 pi by 8 and pi by 4 radians. Okay, just you can observe my notes in, I have provided link in my description. You can download these notes. You have any doubts, just you can discuss in the comment section. Okay, these are all very important problems. This is one more important problem. Sketch the following signal x of t into a sin t minus infinity to t infinity, minus infinity to less than t less than infinity. Very simple. Whether figure from observe, we can figure that periodic signal with period t is equal to 2 pi. Coming to power, energy nor power signal, the formula per power 1 by t into 1 by t means time period minus t by 2 x square of t dt, or p is equal to 1 by t 0 t, in anything you can write. Okay, 0 to t x square of t into dt. Simply substitute the t value here. Time period is equal to 2 pi because the full cycle 0 to 2 pi, right? 0 to 2 pi. From figure x of t, okay, 2 pi 0 to 2, so p is equal to 1 by time period 2 pi 0 to 2 pi a square sin square t dt. Let us take common a square by 2 pi sin square t we can also called 1 minus cos 2t by 2. Do some integration form. Finally you get the value of a square by 2, that is p is equal to a square by 2. You can also find the power. Okay, these are all very important. Just you can check my notes in description. You can find out my link and you can easily download following notes. Thank you so much. Bye.